Welcome to the new class on logic gates. Logic gates are basic building blocks of the digital system. Logic gates are the basic building blocks of the digital system. The logic operations frequently involved in the design of the digital system are AND, OR, NOT, NAND, and exclusive OR. Now let us discuss about AND gate. What is an AND gate? This is the standard symbol of an AND gate. There are two input A and B. The output Y is the A dot B. To explain AND operation, a simple circuit with the two switches in series are shown. It is clear that the current can flow in the circuit if both switches are closed. The current will flow the circuit whenever both switches are closed. Next is the truth table of AND gate. We have two inputs A and B and output Y is A dot B. When both inputs are 0, the output is 0. If any input is 0, the output is again 0. But when both inputs are 1, the output is 1. Let us see a typical application of an AND gate. We have two input AND gate, and the one input is the digital input signal and the other input is the control signal. That is, one of the two inputs, one is a digital input signal and other is a control signal. Now from the knowledge of the AND gate, it is clear that the digital input signal will pass through the AND gate only if the control signal is high or the control signal is 1, or simply we can say that the AND gate is enabled when the input B is high. What are the important uses of AND gate? The first one, selection of data input for a shared bus. Here bus means high speed internal connection. Then to generate new control signals by combining processors signals. The third one, to determine whether external circuit will be enabled. So it is clear that AND gates are used in interfacing circuitry. Let us discuss some AND gate ICs. The first one, 7408, with a logic Y equal to AB. It contains quad 2 input positive AND gates. Here the term quad means that the IC package has 4 units of AND gates. Then 7411 with a logic Y equal to ABC. It contains 333 input positive AND gates. Now 7409 with a logic Y equal to AB. It contains quad 2 input positive AND gates with open collector outputs. In the above example, the IC 7409, the output of 7409 is open collector output. Now for proper functioning of the device having open collector output, the output terminal should be connected to VCC. For proper functioning of the device with open collector output, the output terminal should be connected to VCC through a resistor that is called pull-up resistor. Next we are going to OR gate. What is an OR gate or inclusive OR gate? An OR gate has two or more input and only one output. To illustrate OR operation, a simple circuit with the two switches in parallel is shown with the two switches A and B. We know that the current will flow if either of the switches A or B is closed. Here, an open switch indicates logic 0 and closed switch indicates logic 1. This is the standard symbol of an OR gate with the two inputs A and B, and the output Y is A plus B. Next is the truth table of OR gate with the two input A and B. The output Y is A plus B. When both inputs are 0, the output is 0. If any input is 1, the output is 1. If both inputs are 1, then again the output is 1. Consider a typical application of an OR gate. In one of the two input, one input is power on reset and other input is switch reset, and the output is connected to CPU reset. This is the typical example of OR gate application. As the CPU has only one reset pin, the reset control from the 2 points are made through OR gate. We know that when the power is switched on, the CPU is reset. During the operation, the operator can also reset the CPU through a switch. Therefore, the power on reset and the switch reset are connected to the CPU reset pin through OR gate. The next application is OR gates are used to select data input for a shared bus. Next is NOT gate. NOT gate has only one input and one output. The NOT gate is also known as the inverter gate or inhibitor gate or complement gate. The output of a NOT gate is the complement of the input signal, that is 1's complement. If the input signal is low, the output is high. If the input signal is high, the output signal is low. NOT gates are used to invert the logic levels where it is required. This is the standard symbol of a NOT gate with input A, or the output is A complement. Next is the truth table of NOT gate. The input signal is represented as A, the output is A complement. When A is 0, the output is 1. When the input is 1, figure shows a typical application of a NOT gate. Suppose that IO write and memory write are controlled from the same control signal. When the control signal is high, the output of the NOT gate is low, which is evident from the figure. So IO write is performed. When the control signal is low, the output of the NOT gate is high and the memory write is performed. Now let us see some inverter gate ICs. IC 7404 with a logic y equal to a complement is a hex inverter, which means the IC contains 6 inverters or 6 NOT gates. Next is 7405. It is a hex inverter with open collector output. Next is NAND gate. A NAND gate has 2 or more inputs and only one output. The standard symbol of a NAND gate is shown when we have 2 inputs A and B. The output will be y equal to A dot B complement. The NAND operation can also be performed using a combination of an AND gate and an inverter gate. This is represented in the figure below. The output of the AND gate is A dot B, and when it is connected to an inverter gate, the output becomes A dot B complement. Since we know that A dot B whole complement equal to A complement plus B complement, the NAND operation can also be performed using a combination of 2 inverters and 1 OR gate. This is shown below. We have 2 inputs. The output of the NOT gate is connected to an OR gate so that the output become A complement plus B complement, and it is equal to A dot B whole complement. This can also be represented in the following way. Now let us see the truth table of NAND gate and some gate ICs. If we have 2 inputs A and B, the output is given by y equal to A complement plus B complement or A dot B whole complement. If both inputs are 0, the output is 1. If one input is 0, the other is 1, then again the output is 1. If both inputs are 1, then the output is 0. Let us consider some gate ICs. The IC number 7400 contains quad 2 input positive NAND gates, then 7401, it contains quad 2 input positive NAND gates with open collector outputs. Next is NOR gate. What is a NOR gate? A NOR gate has 2 or more input and only one output. Now for a 2 input NOR gate, the output is given by y equal to A plus B whole complement. This is the standard symbol of a NOR gate. If we have 2 input A and B, the output will be y equal to A plus B whole complement. The NOR operation can also be performed using a combination of OR gate and inverter gate. This is represented as If we have two inputs A and B, the output of the OR gate is A plus B. When it is connected to an inverter gate, the output become Y equal to A plus B whole complement. Since we know that A plus B whole complement equal to A complement dot B complement, the NOR operation can also be performed using the combination of two inverters and one AND gate. This is shown below. We have two inputs A and B. It is initially connected to a NOT gate so that the output become A complement and also B complement. When the output of the NOT gates are connected to an AND gate, the output become Y equal to A complement dot B complement. This is equal to A plus B whole complement. This can also be represented as, it can also be represented in the way that is shown below. Now let us see the truth table and some gate ICs of the NOR gate. The truth table for NOR gate is shown. If we have two inputs A and B, the output is given by Y equal to A plus B whole complement or A complement dot B complement. When both inputs are 0, the output is 1. If both inputs are 1, the output is 0. If one input is 0 and other input is 1, the output is 0. Let us consider some ICs. IC 7402. It contains quad 2 input positive NOR gates. Then IC 7425. It contains dual 4 input positive NOR gates with strobe, and in the logic G represent the strobe. Next, why NAND and NOT gates are so important. We can say that NAND gate and NOT gates have logical completeness, which means that every possible switching operation can be performed using both NAND and NOT gates. Also, it is easy to fabricate NOR or NAND gate compared to OR or AND gate using the IC technology. Also, the NOR gate and NAND gate consume less power compared to OR gate or AND. Next is exclusive OR gate. If we have two inputs, the output is given by A XOR B or Y equal to A complement B plus A B complement. The second figure shows the realization of exclusive OR gate using NOT gate, AND gate and OR gate. If we have two input, the output is given by A XOR B. When both inputs are 0, the output is 0. If both inputs are 1, the output is 0. If one input is 0 and other input is 1, the output is 1. The exclusive OR operation is the same as OR operation, with the exception that the output is 0 when both inputs are 1. What are the applications of exclusive OR gate? An XOR gate can be used for binary addition. The output of an XOR gate is equal to the sum of two binary bits. The carry can be obtained using AND gate. The output of an AND gate is equal to the carry resulting from binary addition. This is the binary addition table. We have two inputs A and B. When both inputs are 0, the sum is 0, the carry is 0. But when both inputs are 1, the sum is 0, but the carry is 1. Some exclusive OR gate IC is given below. The first one is 7486. It contains quad 2 input exclusive OR gates. Next is 74136. It contains quad exclusive OR gates with open collector outputs.